ever pondered on what the difference is between an asteroid whirling through the cosmos and a rock on Earth? There have got to be similarities, right? Or are they completely different? Let's dive into this cosmic conundrum. Picture this. You're standing in your backyard, a small stone in your hand. Above you, the night sky is alive with twinkling stars, planets, and yes, asteroids. The stone in your hand and the asteroids above might seem worlds apart, but they may be more similar than you think. The stone you're holding is a piece of Earth's crust, formed over billions of years through processes like volcanic activity and sedimentary layering. It's made up of minerals, the building blocks of rocks, each with its unique recipe of elements. Some stones are a mishmash of different minerals, while others are almost pure, a single mineral through and through. Now, let's turn our gaze skywards, to the asteroids. These rocky bodies orbit our sun, caught in a cosmic dance that's been going on for over 4.5 billion years. Like the stone in your hand, asteroids are made up of minerals. However, their formation story is quite a bit different. Born from the solar nebula, the cloud of gas and dust left over after the sun's birth, asteroids are like time capsules from the dawn of our solar system. But what about their composition? Well, just like terrestrial rocks, asteroids can be made up of a variety of minerals. Some are rich in silicate minerals, while others boast a high concentration of metals like iron and nickel. And just like the rocks on Earth, each asteroid is unique, its composition a testament to the conditions present when it formed. So as we stand here, stone in hand, gazing up at the night sky, we're confronted with a cosmic conundrum. What separates the rocks of our home planet from those hurtling through the cosmos? Could it be that they're not so different after all? If you think about it, asteroids and rocks might not be as different as they seem. Let's voyage into the cosmic ocean to understand asteroids better. Picture these celestial bodies as islands in the vast expanse of space. These islands, known as asteroids, are a fascinating part of our solar system. Their sizes range from small boulders to objects that are hundreds of miles in diameter. But don't mistake these for your typical island getaway. Asteroids are primarily composed of rock and metal, with some even boasting a shiny coat of nickel and iron. Now imagine a sort of cosmic highway located between the orbits of Mars and Jupiter. This is the asteroid belt, home to millions of these rocky bodies. It's like a bustling city in the middle of a cosmic desert, a stark contrast to the empty void around it. But what makes the asteroid belt so rich in asteroids? It's all due to Jupiter's powerful gravity preventing these chunks of rock from coalescing into a planet. So where did these asteroids come from? Picture a time over 4 billion years ago, during the early stages of our solar system. The sun was just a young star, surrounded by a swirling disk of gas and dust. This material began to clump together, forming the planets we know today. But not all of this material made it into a planet. Some of it was left behind, forming the asteroids we see today. These asteroids are like cosmic fossils, providing us with valuable insights into what the early solar system was like. They're not just chunks of rock and metal, they're pieces of our cosmic history. So the next time you gaze up at the night sky, remember those tiny points of light darting across the darkness. They're not just random space debris, they're remnants of our solar system's past. They're windows into the early days of our universe, waiting for us to unlock their secrets. Asteroids, the ancient remnants of our solar system, are more than just space debris. They're a testament to the incredible complexity and history of our universe, and a reminder that there's always more to discover. Now, let's turn our attention closer to home, to the rocks beneath our feet. These seemingly mundane objects hold secrets of our planet's past, present, and perhaps even its future. Earth's rocks are as diverse as the planet's landscapes. They come in all shapes, sizes, and colors, each type formed through different processes and composed of different minerals. There are 3 main types of rocks on Earth: igneous, sedimentary, and metamorphic. Igneous rocks are born of fire, formed when molten rock or magma cools and solidifies. This can happen either beneath the Earth's crust, creating intrusive igneous rocks, or on the surface when volcanoes erupt, creating extrusive igneous rocks. granite and basalt are two well-known examples of igneous rocks. Sedimentary rocks, on the other hand, are formed from the remnants of other rocks, plant material, or animal remains. These particles, or sediments, accumulate over time and are compacted into rock through the weight of the layers above them. If you've ever admired the layered beauty of sandstone or the fossil-rich limestone, you've seen sedimentary rocks in action. Metamorphic rocks are the shapeshifters of the geological world. They start as either igneous or sedimentary rocks, but under the immense heat and pressure within the Earth's crust, they transform into something new. The sparkling quartzite and the striped gneiss are prime examples of metamorphic rocks. The geological processes that shape our planet, from the fiery eruptions of volcanoes, the steady deposition of sediments in rivers and oceans, to the intense pressures deep within the Earth's crust, have bestowed us with an incredible diversity of rocks. Each rock, whether it's a jagged shard of obsidian or a smooth river pebble, has a unique story to tell. So the next time you kick a pebble down the road or climb a rocky hill, take a moment to appreciate these silent storytellers of our planet's dynamic history. From the towering mountains to the pebbles on the beach, each rock has its own story to tell. So, how do these cosmic wanderers compare to our earthly stones? Let's embark on this curious exploration together. First off, let's talk about what they're made of. Both asteroids and rocks on Earth are composed of minerals. Asteroids, particularly those in the inner asteroid belt, are primarily made of silicate rock and metal, similar to terrestrial rocks. However, asteroids also contain metals such as iron and nickel, which are found in much lower quantities on Earth. Now, let's look at how they're formed. Asteroids are like time capsules from the early solar system. They're formed from the primordial dust and gas that didn't get incorporated into planets. On the flip side, rocks on Earth have a more varied origin. Some form from the solidification of lava and magma, others from the accumulation of sediments, and yet others from the transformation of these rocks under high pressure and temperature conditions. As for age, asteroids take the trophy. They've been around for about 4.5 billion years, virtually unchanged. Meanwhile, Earth's rocks are constantly being recycled through the planet's dynamic geological processes. The oldest rocks on Earth, found in western Greenland, are a mere 4 billion years old. Interestingly, some rocks on Earth are actually pieces of asteroids. When an asteroid collides with Earth, it creates meteorites. These meteorites, once they survive the fiery journey through our atmosphere and land on our planet, become terrestrial rocks. They carry with them a glimpse into the vast cosmos, a little piece of the universe right here on our home planet. So, while asteroids and Earth's rocks may initially seem worlds apart, they're more similar than you might think. They both carry within them the story of our solar system, from its fiery beginnings to the present day. They're both composed of minerals, they're both subject to the forces of the universe, and they both have a story to tell. Despite their different homes, asteroids and rocks share a surprising amount of common ground. So next time you pick up a stone, consider its cosmic connections. You might be holding a piece of the universe in your hand. Now, you might be wondering, is there a connection between asteroids and the rocks on Earth? Well, the answer is a resounding yes. In fact, asteroids have played a significant role in shaping the Earth's history. Picture this: a colossal asteroid hurtling through the vastness of space, drawn in by the gravitational pull of our planet. Upon impact, it triggers cataclysmic events, reshaping landscapes and influencing the course of life itself. Yes, these celestial bodies have the power to alter the destiny of our planet. But it's not just about destruction. Asteroids have also been the bearers of gifts. They've brought with them materials foreign to our world, including precious metals and other elements. Some scientists even suggest that asteroids might have delivered the first water to our planet, filling our oceans and making life as we know it possible. Beyond that, asteroids might have even sown the seeds of life itself. Complex organic molecules, the building blocks of life, have been found on asteroids. It's conceivable that these molecules, brought to Earth by asteroids, kick-started life on our planet. Studying asteroids, therefore, is like peering into a cosmic time capsule. These ancient bodies are remnants from the early solar system, virtually unchanged for billions of years. By analyzing them, we can uncover secrets about our planet's early days, shedding light on how the Earth and possibly life itself came to be. So, the next time you pick up a rock, remember, it might just hold a cosmic secret. It could be a fragment of an asteroid, a piece of the cosmic puzzle, bearing the tales of our planet's past, and perhaps even the keys to its future. Each rock, each asteroid, is a testament to the intricate cosmic connection that binds together the Earth and the vast expanse of space. We hope you enjoyed watching this video. If you did, like this video and subscribe for more content.